In this lab, we tried to find and analyze all the different forces that were exerted during a sports activity using torque. For my group's example, we chose tennis. We chose to analyze the forces exerted on a tennis ball when it is hit with a racket during a match of tennis. For this specific example, we had Mason, a member of our team, stand about 3 meters from a wall and horizontally hit a tennis ball with a tennis racket. With this task, we recorded the time it took the ball to hit the wall after being hit with the racket. We also used the internet to look up the average weight of a tennis ball and a tennis racket, as well as the average mass of a grown male's arm. With this information, we drew a free body diagram as shown above, and were able to find the velocity of the ball, the momentum of the ball, as well as the impulse. We were also able to find the possible velocity of the arm as well as the force of the bicep. To find these values, we used the formulas listed above. We used the equation for torque with angled forces, which is T equals Fr sine theta. And we also used Newton's second law, which is F equals mg, which describes force. And we also used the equation P equals mv, which describes momentum. We also used J equals F times the change in T, which describes impulse. With these equations, we found that the ball was traveling at a velocity of 7.5 meters per second with a momentum of 3.825 and an impulse of 66.408. We also found that Mason's arm was going at a velocity of 0.67 meters per second and had a force of about 166.02 newtons. All these values were found using the formulas listed, and all of the work is right below the formulas, as you can see on how we found these answers. Just some additional information, the sources that we used to find the average mass of the arm and the tennis ball and racket can be found under the acknowledgements in the bottom right-hand corner.